All right, Pre-Cal 12, let's get after it. Here we go. We are up to video 27. We're looking at section 6.3. We're talking about general and special angles. So in this scenario, we're going to dive back into our special angles 30, 60, 90, 45, 45, 90 that we looked at in both grade 10 and 11. We're going to dive a little deeper. We're going to look at it with radians, but we're also going to look at angles called quadrantal angles, which are going to be very important when we get to section 6.4 on graphing. So here we go. A quadrantal angle are kind of your four biggies because they have specific special scenarios. So we have 0 degrees or 0 radians. And the important thing to consider is that here r is 1, your radius is 1, but here x is also 1 and y is 0. Okay, because we have no height. So you can imagine your triangle that we normally have is just smushed right down. It's lying right down. The line is lying on the x-axis. So the height of our triangle is non-existent, and the radius of our triangle is our x value. So that's at 0 degrees, 0 radians. And you'll see the relationship here with cosine, sine, and tangent with respect to these. I'll just do those for just this one, and then you can kind of see that. So remember that sine is y over r. So in this case, y is 0, r is 1. So sine of 0 degrees or 0 radians is 0. Cosine is x over r, and since x and r are the same, we get 1. And then tangent is y over x, so we get 0, right? So you're going to get some pretty specific values for these, and they're going to be, again, really handy when we get into graphing sine waves, cosine waves, tangent waves. So the next one is when we get to 90 degrees, or pi over 2 radians. And you can see this time our y value is equal to 1, our r is equal to 1, but our x is equal to 0. When we get to 180 degrees, or pi, here's where things get interesting. Our x value is negative 1, our y is 0, but remember r is always positive, so our radius is still positive 1. So that's going to affect our location and the sign of our answer. So you'll notice that cosine of 0 and cosine of pi are both 1, except one of them will be negative 1 because of the sign change of our location. So that is how this ties in. You're going to see how these relate to our graphs in the next section. And then the last one here, we now have, in this case, r is still 1, but now y is negative 1 and x is 0. And this is when we are at 360 degrees, or sorry, no, not 360, 270 degrees, or 3 pi over 2. So these are going to be our really important scenarios. 0 radians, pi over 2 radians, pi radians, and 3 pi over 2 radians. And you're going to see them come back again. Because remember, when we get back to 360, we're back to 0. When we get back to 0, or 2 pi radians, we're back to 0 radians. And we just continue that loop. So those are your quadrantal angles. So let's calculate some of these. So what is tan of 90 degrees? Well, tan of 90 degrees, if we think about this on a grid, right, where's tan of 90? It is my line that lies right there. So I have an r value of 1, a y value of 1, and an x value of 0. And tan of 90 is y over x. So I get tan of 90 is 1 over 0. So I cannot solve that. So tan of 90 is undefined. Your calculator will give you error 1 because that is, or sorry, no, error 2. Error 2 means it's a domain error. It's not allowed. Error 1 is a syntax error. You've typed in wrong. So if you get error 2, you get an undefined solution. So now what about sine of 180? Well, again, let's draw our little grid here. Where is that line? Well, that line is lying right here, right? So in this case, my y value is 0, and that's really all the information I need. My r is going to be 1. So sine of 180 is 0 over 1, which is 0. Cosine of pi, well, again, pi is exactly the same as 180, so we exist here. But now in this scenario, we're interested in x. X is -1, r is 1. So we end up with -1/1 because we're cosine, which gives us -1. So you can see these quadrantal angles are going to produce values or sometimes undefined values. And then last, we're looking at cosecant of pi over 2. Now, pi over 2 is 90 degrees, and cosecant is r over y, right? The reciprocal relationship of sine. So here y is 1 and r is 1. So we're still going to have 1 over 1, which gives us 1. So that is the relationship of all of our, well, not all of them, a few examples of our quadrantal angles and how we can calculate them. So let's move on. What happens if we are outside of one revolution? So we have some coterminal angles here. Well, let's get back to within one revolution of rotation. So tan 180 is way too many revolutions, right? So if we take tan 180 and we subtract a number of 360 revolutions, we will actually end up getting back to 0 degrees. And by getting that, we're then looking at, okay, well, what's tan of 0 degrees? Well, 0 degrees is here. We have a y value of 0 and an x value of 1. So tan of 0 is y over x, which is 0 over 1. So tan of 0 is 0. So that means, or sorry, yeah, y of 0, x of 1. So there we are. And now we are going to look at secant of 11 pi over 2. So for this one, again, we are way more than 2 pi over, right? In this case, if you have a denominator of 2, 2 pi is equal to 4 pi over 2. So if we go 11 pi over 2, and we subtract 2 rotations, that would be 8 pi over 2. So we subtract 2 full rotations, now we fall at 3 pi over 2. And 3 pi over 2 is equivalent to 270 degrees. So we're down here. So what are our values here? Well, r is 1, x is 0, y is -1. And since we're dealing with secant, just erase this, we did that calculation. Since we're dealing with secant, that is the reciprocal of cos. So we're looking at r over x. So in this case, we have 1 over 0. And we cannot do that, so we get undefined. So secant of 11 pi over 2 is undefined. It all comes back to getting to our coterminal angles, which produce, in this case, one of the quadrantal angles. And then lastly, we have cosecant of 7 pi. Well, 7 pi is outside of our 0 to 2 pi revolution, so let's roll around again. So we'll take away 2 pi. That'll leave us with 5 pi. Well, we're not there yet. Take away 2 pi. That'll leave us with 3 pi. We're still outside. Take away 2 pi. And when you look at that, we end up at pi. So 7 pi is the same as pi, so we exist here. And in this case, we have r as 1, x of -1, and y of 0. And we're looking at cosecant, which is the reciprocal of sine. So in this case, we have r over y. And you may see right away, well, y is 0. It's going to be my denominator, so this is also undefined. So you can see we're tying all of our coterminal, and in this case, not a special angle because it's a quadrantal angle, but we're still tying those particular angles to coterminal scenarios. So these are going to come back again and again and again. Get really comfortable with them, and they're really good ones to know. So now let's revisit our special angles. So remember, our special angle triangles look like this. And we have particular ratios. So across from the 30 is 1, across from the 60 is root 3, and Pythagorean theorem gives us 2. There's a pretty good proof in my video, I believe in grade 11, on how we come across that. You use concept of similar triangles, you will always end up with this ratio. You can actually scale this down to a unit circle as well. I'll do that for you just for fun. If we're going to scale this down so that the hypotenuse is of length 1, you would divide everything by 2. And then you would notice that that's your special angle right there. That's your special angle right there because you're dividing by the hypotenuse of 1. And then the only one that's a little bit trickier is going to be your tangent. But you'll see that the denominators will cancel out, so on and so forth. By this point, I think you're comfortable with your algebra. So let's fill in this table. Sine of 30 degrees is 1/2. I'm going to change to a black pen. Cosine of 30 degrees is √3 over 2. Tangent of 30 degrees is 1/2 over √3 over 2, so 1 over √3. Cosecant, well, now we're just into the reciprocals. So reciprocal of sine, reciprocal of cos, and reciprocal of tan. Boom. So there's our first chunk. For 60 degrees, we can use the same triangle, except this time we have √3 over 2, 1 over 2, √3. And then again, we are taking reciprocal values. So 2 over √3, 2, and 1 over √3. So those are going to be our special angles. I always recommend drawing this thing on your page so you're staring right at it, because you want these to become relatively instant. You don't want to have to look at a table all the time. So now what about 45, 45, 90? Well, this one's way easier because it's 1, 1, √2. Again, if you wanted it as a unit circle, you would divide everything by √2, and it'll just give you your ratios right off the bat. So sine is 1 over, again, here we'll go to black, 1 over √2, 1 over √2. Cosine, or tangent is just 1, and then reciprocal. So √2, √2, 1. Now, the reason why we point this out is because the special angles will appear again and again and again, but they will appear as reference angles. So what will change is the sign of the ratio. So let's have a look. Here we go. I make a big fuss here. It is imperative that we remember reference angles. So sine of 300 degrees. Well, where is that? Sine of 300 degrees is here, right? What's the reference angle of 300 degrees? Well, reference angle is 60 degrees. So we actually have a sine of 300, which is similar to sine of 60. 60. And what was sine of 60? Well, sine of 60 was √3 over 2. So sine of 300 will also be √3 over 2, except since we're in quadrant 4, we're negative √3 over 2. So that is going to be your subtle change. So be very aware of that. It ties in again to quadrant location. So now let's look at tan of 5 pi over 6. Well, where is 5 pi over 6? That's almost 6 pi over 6, which would be pi. So that means we're here. This is 5 pi over 6. So what's my reference angle? My reference angle is pi over 6. Now in this case, tangent in Q2 is negative because my x value is negative. So tan of 5 pi over 6 is exactly the same as tan of pi over 6. And tan of pi over 6 is equal to 1 over √3. So does that mean tan 5 pi over 6 is equal to 1 over √3? No, it means it is negative 1 over √3 because we are in quadrant 2. So the quadrant is going to be incredibly important. So now lastly, cosecant of negative 5 pi over 4. Well, of course I'm going to throw a negative angle at you. It means we're rotating in a negative realm, but we're rotating past pi. So we're rotating all the way to here, right? So it doesn't really matter that you've gone 5 pi over 4. All that matters is that this is pi over 4. So again, there's my reference angle. Now remember, cosecant is related to sine. Sine is positive in this quadrant, so I know my answer is going to be positive. Pi over 4 is 45 degrees, so this is a nice one, 1 over √2. But since it is cosecant, it's the reciprocal of that, so √2, and it's positive because we're in positive quadrant for sine. So that's how we're going to tie it all together. The quadrants matter, the reference angles matter. We go from there. So let's do a few examples. It helps to draw. So find the smallest possible angle in both degree and radian measure of sine negative 1 over √2. So if we want the smallest possible, that sine is negative in Q3 or Q4, but we want the smallest, so we're going to be in Q3. Now again, I'm not drawing to scale, so it's just for location. Now what I know then is I know that this is negative 1, and I know that this is √2. And looking at those numbers, they jump off the page for me. That tells me that my reference angle is 45 degrees, or pi over 4 radians. But since I'm in Q3, That's my reference angle. So my full theta value is going to be 180 degrees plus 45, which is 225 degrees, or it's going to be pi plus pi over 4. Now, if you're freaking out about adding pi to pi over 4 all the time or subtracting, just remember when you have, boom, if you have pi, it's 4 pi over 4. So you get 5 pi over 4. So knowing which location it in helps you determine. And then you can plug these values into your calculator and you can see how these ratios and their signs match up. So let's do another one. In this case, we need the smallest possible theta for cotan of negative 1 over 3. So cotan, similar to tangent, is going to be negative in Q2. So we're going to have our line here. And remember, not to scale, not an accurate drawing necessarily. I'm just drawing it for location placement. So for this, we have, remember for cotan, it's x over y. So my y is negative, or my y is root 3, my x is negative 1. So what triangle is that? Well, that means a reference angle of 60 degrees or a reference angle of pi over 3. So what's it give me for solutions? Well, that's my reference angle. So this theta, the theta I'm concerned with, is pi minus pi over 3, which means 3 pi over 3 minus pi over 3, which is going to give me 2 pi over 3, or 180 minus 60, which gives me 120 degrees. So you found your exact solutions. Again, this is about exact solutions, not plug it into my calculator, because the exactness of the solution is the refinement that we are looking for. So another one. Find all theta between 0 and 360 and 0 and 2 pi. So we're going to have multiple solutions here, where cosine is equal to root 3 over 2. So cosine is positive in both Q1 and Q4. So we're looking at this. We have this kind of makeup. And cosine is root 3 over 2. Well, 2, 2, and then this is my root 3 value here, which means I have 1, negative 1 for my y values. But what that tells me is that my reference angle is 30 degrees. So my two solutions are going to be in Q1, 30 degrees, and in Q4, 360 minus 30 degrees. So 330 degrees. So those are my two solutions for degrees. Now for radians, 30 degrees is pi over 6. And in Q4, I'm going to have 2 pi minus pi over 6. Well, what's 2 pi? It's 12 over 6. So I get 11 pi over 6. Boom. So there are my 4 solutions for this scenario. We got one more to go. So exact solutions for cosecant negative root 2. It might help you to go, okay, cosecant of negative root 2 means sine of negative 1 over root 2. It just might be a little bit easier for you to consider it that way. Now what we have in this case is we have sine and cosecant, right? Negative in Q3 and Q4. And if we consider this with respect to sine, we have negative 1 root 2, negative 1 root 2. So this is jumping off my page to me. My reference angle is 45 degrees, or pi over 4. So I have Q3. We'll do both here. So Q3 for degrees is 180 plus 45, which is going to give me 225 degrees. And I have pi plus pi over 4, which gives me 5 pi over 4. So those are my solutions for Q3. And then in Q4, I'm going to have 360 minus 45, so 315 degrees, and then 2 pi minus pi over 4, which is 7 pi over 4. So that is it. We are tying special angles and what we saw earlier, quadrantal angles, to unit circle or our special angle triangles. We're considering what quadrant we're in to give us positive and negative values of the given ratios. And we're tying everything we've learned together. The frustrating part for you might be fractions with your radians, but guess what? Deal with it. Fractions are lovely. Okay? Thank you so much, and I will see you next time.